So, hi everyone. I have the pleasure of being the last talk of the day and in the session, and actually the third NYU talk in a row, which was, I think, a total coincidence. But yeah, I'm here to present this paper to you on how much effort is enough, fairness and algorithmic recourse through the lens of substantive equality of opportunity. I'm Andrew Bell, and this work is joint with my colleague Joao Fonseca, who's also at NYU, and then Carlo Abrate and Dr. Francesco Bonchi, who are at Centai in Torino, Italy, and then Dr. Stoyanovich, who was previously my advisor while I was at NYU. Okay, so I'm going to begin with an introduction about algorithmic recourse in similar flavor, actually, to the way that Kate gave an introduction, but maybe through a slightly different framework or different lens. Importantly, as we all have heard, algorithmic recourse involves enabling individuals to take action against the outcome of an algorithmic decision-making system. It's generally concerned with why an outcome was produced by a system, but then also importantly, like what can be done in order to reverse that outcome. And one way to kind of think about this, or one framework, is that an applicant begins an initial application. The most classic example is thinking about a loan, applying for some kind of loan at a time step T0, and then they may be rejected by that AI system and receive recommendations on what they can do to make changes so that they will receive a successful outcome in the future. These recommendations might be things like, okay, try and increase your income by X dollars or reduce your outstanding debt by Y dollars. And then there's some implied passage of time that happens there, some time delta. The changes that we're talking about here are those that happen on the order of maybe months or even years in order to change your income or substantially lower your debt to where it could have an impact on these systems. And significantly, this can cause things like concept drift, which is the natural tendency of models to kind of degrade over time, or there's just real world changes that may be kind of impacting this ecosystem in unexpected ways. And the criticality of time and the importance of time was actually the foundation of work by the exact same group of authors, also at EMO 2 years previously in 2023. And so the title of that paper is Setting the Right Expectations, Algorithmic Recourse Over Time. But one of the contributions of that paper was that we actually developed an agent-based model for recourse over time. I think one of the challenges of working in this area, there's so many important questions, but it's really hard to find real-world data sets. And at least I'm not aware of any publicly available real-world data sets, even in the lending example, where you can kind of track outcomes and see what's happening over time. And so, one effort, I guess, in some ways to try and at least fill this gap or get some intuition on maybe what are some unknown unknowns in that area, we had proposed this agent-based model. And I'm going to call upon this quite a bit in this work. It builds upon this, so it's worth kind of talking through this little diagram here. So on the x-axis, we have the time steps. So these, it could be months or year, whatever kind of discretization, however you want to discretize time. And then on the y-axis, we have individual scores according to some AI system. And so here it's mapped on like a 0 to 1 scale. And so you can imagine all these individuals apply for a loan, let's say at this time step, and here the cutoff was like 0.7 for receiving a positive outcome. And so anyone who's below that threshold would receive some changes, recommended changes that they need to implement in order to kind of cross that decision boundary. And this was the emphasis of a lot of what Kate was talking about in her setup here. And so the challenge here is that by the time you arrive at the next time step, this system could have changed. It's possible now that this recommendation was unstable, and the impact of time has now made it so that a higher threshold is needed to receive a positive outcome. And this could be because the setting is resource constrained and things are getting more competitive, could just be policies that have changed at the bank, and any number of kinds of things. And so in this framework, you can play with all these different parameters. There's actually a web application you can use to kind of run this and see the evolution over time, and kind of try and understand how these different inputs like the population size, the competitiveness, these different functions that govern agent behavior impact the outcome of this system. And one thing I'll just call out actually quickly, which is kind of a little bit planting the seed for the takeaway of the work I'm going to talk to you about today, is that we learned that it's really, really difficult to parameterize even that agent-based model, that simple agent-based model, to be stable over any number of time steps, like as soon as you start to hit 5 or 10 time steps. So if you buy that the real world is at least as complex as our agent-based model, that means it's likely also very difficult in the real world to parameterize these things correctly to have stable recourse recommendations. And so kind of bearing that takeaway in mind, I'm now going to talk a little bit about how we think about fairness and recourse, and again, building on this agent-based model. So, one way to kind of think about perhaps what is kind of fair in the setting could be something like thinking about purely about outcomes and fair selection. So here again, I have the same diagram, and now we have an advantage group in blue and a disadvantage group in orange. And in this case, we're selecting two individuals, one from each group, and so there might be kind of some notion of fairness that's being satisfied. But past work has really importantly called out that one major problem with this setup is that if you look at those that did not receive the positive outcome and you look at their average distance to the decision boundary, you can see for the blue individuals, they have a score of 0.45, so they're further along. And the orange individuals, it's like 0.3 would be their average. And so there's some kind of disparity here in the group-wise distance to the decision boundary. And so, as I mentioned, there's some really great, like highly recommended if you want to get into this area works to read by that are listed here below. That kind of talk about different distributions that you can actually satisfy that fair selection property that end up with this problem of different group-wise distances to decision boundary. And we also introduced some other distributions that were not yet seen in literature, just kind of showcasing like how many different scenarios this can happen under. And so there's been, these works that are here, all kind of also propose mitigation strategies for trying to prevent this, and kind of introduce this notion that we characterize in our paper as score fairness, which is this idea that you actually try and satisfy that the distributions here are similar across groups. So in this case, you can see, among those individuals that didn't receive the positive outcome, they have approximately the same score. And this is the way that we kind of express it with the expected score over those that didn't receive the positive income or positive outcome. And then we can go, while this can be, while this is already like a nice improvement over kind of what we had seen previously, there's also some potential issues that arise from here, which come into play when you think about this notion of effort, which is perhaps group-wise ability to increase your score at all or cause any movement here. And in this work, we actually define effort very broadly. Like it could include things like individual effort or grit or that type of effort, but also things like resources or assistance or anything like that that you might also contribute to increasing your score. So in the loan example, this can be highly relevant both with respect to moving your actual score, but when we think about the time issue, perhaps you have access to like family assistance that can help you reduce your debt or help increase your income in some way quicker than another group. And so there's context where we want to take this into account and try and maybe perhaps mitigate unfairness along this dimension. And so this is where we introduce this idea of effort fair. And what we really care about here is we're thinking about successful recourse events. And what we want is a balance of after the initial score and effort is applied, that we're having a similar expectation of successful recourse event among these two groups. And actually, I'm going to get into the empirical evaluation, and this will probably make that a little more concrete, are these two different metrics that we propose. So the first is this idea of effort to recourse, which is about measuring the average group-wise effort for a successful recourse event. So, in its most simplest terms, you look at all those individuals from both groups that were able to churn from a negative outcome to a positive outcome, and then you see have they been exerting similar levels of effort to get there. And then similarly, as I mentioned, I've been emphasizing the criticality of time here. We could also think about this in some ways on a time scale about time to recourse, which is the same idea. Even if groups maybe have a similar, amount of effort that it takes, perhaps the disadvantaged group, it's actually taking them longer to achieve that same level of effort. And so we use our agent-based framework to kind of have run a series of experiments. And I think the way I wanted to present this is I'm actually just going to kind of talk to you about the framework and some of the takeaways. But I recommend either looking into the paper, or there's also a link to the actual website, and it's a Streamlit application. You can play around with this. We have all of the different knobs and levers that I'm mentioning here, plus more that you can play with if you're curious. But so we start by first looking at three different effort distributions. So one in which the advantage group is able to, they draw from, an effort distribution that is less than that of the disadvantaged group, one where they're equal, and then the opposite of that. And then we also look at what we characterize as qualification in the paper, but what this really refers to is just that distance between these two groups, the advantage group and the disadvantaged group. So if the qualification is 0, that would mean that the groups are actually very similar in terms of how features are drawn and their initial scores from the scoring model. And then 3 would be they're very, very different populations. And then we also look at some different mitigation strategies. So one that we propose in the paper is we refer to it as CNS, or circumstance normalized selection. And what it really is just group-wise selection among those individuals that are taking recourse action. We also implement a version of counterfactual data augmentation, which is from Ferraro and Loy's 2022 paper. Yeah, I won't get into the details here. If you want to ask me in Q&A, or we'll talk about it later. It's a cool method that has to do with like retraining your model at every step. And then we combine these two methods together. And then we also have implemented some of the methods from other papers mentioned previously, like Gupta et al. In 2019. We found in our experiments that CNS and CDA combined, these can work together, produce the best results when mitigating effort fairness and effort to recourse and time to recourse on those metrics. But I think the other takeaway that we had again here was just the difficulty in overcoming either differences in qualifications or differences in effort distribution. This scenario, this ecosystem over so many time steps is like so much more unstable than you would think. And recourse and recommendations just become, as soon as that decision boundary starts moving around at all, they just become totally out of whack. And so a similar takeaway that we have here. And I know I'm pretty close to time, but just in my last minute and a half here, the takeaways here, we provide kind of these two different tool sets. The one are those metrics that I mentioned about, and then also this web application that I've been mentioning. And again, we kind of really expand on this lesson about how it's very, very difficult to parameterize for stable and fair recourse over time. And the implication here is that practitioners or anybody who's actually going to be implementing recourse in the real world need to really think carefully about this and be assessing at a lot of time periods how stable the system is and how things are working. And then the other thing that I wanted to kind of call out here is, we've seen some work in algorithmic fairness and also some of my background. One really cool thing about that field, I think, is this consensus that there isn't one single fairness metric that you can apply to every situation. Like, fairness is very context dependent. And what's great is we have this giant toolbox of different metrics that we can call from, depending on what the context is. And, I think what this paper represents is one could imagine a similar set of metrics when trying to evaluate the fairness of recourse. And I'm not sure if effort fair is applicable to every scenario or score fair or selection fair, but at least now we have a toolbox where we can assess, okay, who are the stakeholders, who's impacted, who's at risk here, and then make our decisions based on that. And that's the end. Thank you.
All right. Yeah, we had quite a New Jersey, New York folks.
Yeah,
Reading
right?
the last section.
It's funny.
Okay, we have maybe 1 or 2 questions from the audience.
Hi, thank you for this talk. This is really interesting. I have a question about how, do you have a sense of how the different scenarios you explored in the simulations, are there sort of real world analogs that you're thinking about, or are you able to kind of look at any sort of empirical examples of this? And I know you mentioned that data on this is hard, so maybe that's impossible, but curious if you have thought or looked at that.
Yeah, it's a really great question. And I unfortunately, I think I give like a little bit of a cynical answer. So when we first worked on this work like a year ago, I was really enjoying the agent-based simulation. But I think right now with Recourse, I'm in a little bit, I really want to see some real world data because it's really hard for me to map these things over. Our simulation is not overly complex. Like we have different behaviors that you can have for like governing, for example, is an individual are they more likely to be discouraged if they're very far away from the decision boundary, or is there some like motivation effect? Are there competitive effects? We thought it out and tried to implement a lot of different scenarios, but it's still not overly complex. And even then, it's so difficult, as I'm mentioning, to like, if you play with it, to parameterize stable recourse over time, which makes me really, really, really want to see some real data or some real information on this. So I think like my question or my answer, I don't know if I answered it directly, but it's more of like a call to action of like, oh, I'd love to work with some real data in the setting or partner with, you know, a bank who's actually using one of these systems to like really understand what's happening and how people are being impacted in the real world.
Any other final questions?
Just to respond to her question, I think I wrote a
Yeah.
review paper on long-term fairness like a year and a half ago,
Okay.
and I had the same call for new data sets, and it's not happened. So I'm not too optimistic that it will happen anyways.
Yeah.
But to your part where you talked about the mean distance for the average group for the from decision boundary, I'm wondering how this would work with or comparatively work with if you had like a bounded effort, because there's some works that try to bound the effort to equalize, because like you mentioned, the effort could vary between individuals based off of the resources they have. So
Yeah.
I'm wondering how that would.
Yeah, I would need to think about that a bit more deeply, but my initial thoughts are that this would be compatible with that. And I think actually it would probably, it's kind of acting as a constraint in some way, which I think would add even more complexity into, make it even more difficult to be able to balance things on effort fairness. But yeah, it's a good call out, because we use like a very simple notion of how effort is measured here, where we're just drawing simply from a distribution, and we're kind of looking at distances between these fixed distributions. But it's an interesting idea to start thinking about how to bound that effort distribution and provide constraints there and things like that. Yeah. It sounds like you've worked in this area, so I'll talk to you afterwards, and yeah, I'd love to hear more about it.
Okay. Any final questions? Right. Yeah, so
Right.
thank you, Andrew, for
Thanks a lot.
being the
Thanks, everyone.
first energy to close out the day.